Hello everyone, welcome to my mathematics workshop. So, to know more about me, I am Janopol Bangahon, a grade 12 GAS student. For this workshop, I chose to have mathematics to freshen up my knowledge and skills about math because we actually don't have math in our subjects. And the last time our class had it is when we were in grade 11, first semester. My love and passion for mathematics started when I was in grade 7, specifically when algebra was introduced to us. So, now, for this workshop, I prepared four different worded problems associated with algebra, and some of these questions are actually from our previous classes that made me help enhance my critical thinking skills. So, for the first question, we have what is the sum of all numbers from 1 to 100? There are two ways to answer this question. First is by using the formula for getting the sum of an arithmetic sequence, which is the sum is equal to n over 2 multiplied by the quantity of 2a plus the quantity of n minus 1 multiplied by d. A is the first term, d is for the constant difference, and n is for the total number of terms. Using the formula, we can get the answer 5050. But we can also get the same answer without using the formula we had a while ago. This way of solving was taught by our science teacher back then, and it's quite fascinating. So what we should just do is to find the pattern in the given problem. A pattern where all the numbers can be paired to 50 pairs of 101 each. So if we look at the table here and add the first term and the last term, we get a sum of 101. And if we did it to the next terms like 99 and 2, we also get 101. So you'll realize that the sum will always be 101, right? And as you have 50 pairs of wheat, we can just simply multiply 101 to 50 and get the same answer, which is 5050. You can try it on your own, guys. So with that, we can get the answer without using any formula. Let's head on to the next question. What we have here next is a type of age problem. John's father is 5 times older than John, and John is twice as old as his sister. In 2 years' time, the sum of their ages will be 58. So how old is John now? So we have to identify the current age of John with the help of his father and sister's age. So in every age problem, guys, you should always remember the corresponding mathematical symbol to the word stated. And the last statement in the problem will always be in the equation. Just like in our example, in 2 years' time, the sum of their ages will be 58. How old is John now? So the sum of their ages will be 58. Before we compute for the example, let's first identify their unknown ages using variables. So it started with the statement, John's father is 5 times older than him. Since we don't know John's age, this will be the x, and his father's age will be 5x. Next statement, and John is twice as old as his sister. He's older than his sister, so 1.5x will be the sister's age. The next table represents everything we need to get onto the solution part. These are just their ages in 2 years. For the solving part, we just have to add them together and solve for x. Solving for x, we got the answer of 8, and this will also be the age of John currently. His father's age is 40, and his sister's age is 4. To check his age, you can just simply evaluate by replacing x with 8 and solve if the equation will be equal to 58. Next topic is about solving polynomial function using factoring. Here we have the example p of x is equal to 2x cubed minus 3x squared minus 18x plus 27. First, we just have to equate them to 0, and the easy way to solve it is to factor them by grouping. I group 2x cubed minus 3x squared and negative 18x plus 27. Next is to factor them, so the equation will be x squared is multiplied by the quantity of 2x minus 3 plus negative 9 multiplied by the quantity of 2x minus 3 equals 0. We can factor out 2x minus 3, so we are left with the quantity of 2x minus 3 times the quantity of x squared minus 9 equals 0. And now, we can solve for x on each set. X is equal to 3 over 2, and the square root of 9 is positive and negative 3. So x could be either 3 over 2, positive 3, or negative 3. It's easy as that. So let's go to the last problem, which is a type of circular permutation. Now, this problem is somehow an advanced type of permutation problem, but I'll do my best to show you how it is done, especially for the viewers who haven't tackled this lesson with Teacher Brahet. But before that, permutation is an arrangement of something to its sequence or order. Like in our problem here, four men and four women sit at a round table at a family dinner. So in how many ways can they sit if three particular people must not sit together? So permutation is a mathematical technique that determines the number of possible arrangements in a set when the order of arrangements matters. Because combination in the other hand is used to determine the number of possible arrangements in a set when the order does not matter. So for the formula for permutation is P is equal to the quantity of n minus 1 times factorial. N is for the total number of objects. So to solve for the problem, we should first solve for the total number of ways they can sit and subtract it with the number of ways three particular people must not sit together. So since we have 8 people, the total number of ways is 7 factorial, or 7 times 6 times 5 times 4 times 3 times 2 times 1. So the answer is 5040 ways. And to get to the number of ways 3 people must sit together, we can just separate the 3 people, find their factorial, and multiply it to the remaining people, which is 5. So 3 factorial is 6, and 5 factorial is 120. 6 times 120 is 720. Now let's subtract 5040 to 720, and we got an answer of 4320. So the number of ways 4 men and 4 women sit at a round table that 3 particular people must not sit together is 4320 ways. So that is all for my workshop. And I hope that you learned something from my video. So thank you everyone and have a good day. Bye bye.